What is the nearest habitable planet? Many of us on Earth are asking this question. The search for life on Mars, the closest habitable planet to Earth, began in the 19th century and continues today with in situ exploration missions. Rovers are regularly sent to the Red Planet to collect samples of Martian soil that may give us clues about past or present life on Mars. However, no extraterrestrials have been found on Mars for the moment. The Red Planet is located in the Sun's habitable zone, but at its extreme limit, so that it's very cold with an average temperature of -63 degrees Celsius or -80 degrees Fahrenheit, compared to 15 degrees Celsius or 59 degrees Fahrenheit for the Earth. The discovery of the first exoplanet, 51 Pegasi b, on October 6, 1995, changed things considerably. Exoplanets are planets that orbit a star other than the Sun. To date, more than 5,300 exoplanets have been discovered, according to the Encyclopedia of Extrasolar Planets. But not all exoplanets are habitable. Some orbit very close to their star, and others are ice planets like Uranus or Neptune. And less than 200 of the exoplanets discovered are rocky like the Earth, the others being gaseous like Jupiter. The search for a habitable exoplanet has become one of the objectives of astronomers who study the characteristics of each exoplanet discovered with powerful telescopes in the hope of finding biosignatures, i.e., traces of life. Dear traveler, welcome. Today, several star systems are of interest to astrophysicists. Among them, the star system of Wolf 1061 arouses the curiosity of scientists. Located at 13.8 light-years from Earth, which is a relatively close distance on the scale of the universe, this star system hosts an exoplanet, Wolf 1061c, which would be one of the closest potentially habitable exoplanets. What does Wolf 1061c look like? Does it resemble the Earth? Is it possible that there is life on Wolf 1061c? And if so, what would it look like? All these questions you ask yourself, astronomers also want to get the answers. It's time to go and explore this star system, which is close to our Earth and has intrigued scientists for several years. But before leaving for a new adventure, think of liking the video and subscribing to the channel so as not to miss anything. Thank you, and fasten your seatbelt. Immediate takeoff for Wolf 1061. The Wolf 1061 star system is located 13.8 light-years from our solar system. Between the Earth and Wolf 1061, there is no vacuum, quite the contrary. Space, contrary to what many think, is not empty. There is no air, but there are gases, dust, molecules, and atoms. There are also many celestial objects: stars, exoplanets, satellites, comets, pulsars. There would be about 30 stars between the Earth and Wolf 1061. On our way, we will cross a multitude of stars, some of which are the center of a planetary system. Wolf 1061 is not the closest exoplanet to Earth, but it is one of the few exoplanets that seem most likely to harbor life. We will take advantage of our trip to the Wolf 1061 star system to observe several exoplanets that astronomers have already studied in hopes of finding traces of extraterrestrial life, On our way, we will pass several exoplanets that are already candidates for the title of the closest exoplanet to Earth where life exists. First stop, the Proxima Centauri planetary system. Located 4.2 light-years away in the Centaurus constellation, Proxima Centauri is officially the closest star to the Sun. It is also called Proxima Centauri, Alpha Centauri C, or Alpha Centauri C. Proxima Centauri forms with the stellar pair Alpha Centauri A and B, the Alpha Centauri system. Despite its proximity to Earth, Proxima Centauri is not the brightest star in our sky. That title goes to the star Sirius, located 8.6 light-years from Earth, which is only the 5th closest star system to the Sun. If Proxima Centauri is not that bright, it is because it is a red dwarf. Red dwarfs can be up to 1,000 times less luminous than the Sun. And then, its mass is only 1/8 that of the Sun, which explains why Proxima Centauri is so dim. On August 24, 2016, an exoplanet was detected orbiting this red dwarf star, Proxima Centauri b. This is the closest exoplanet ever found. Proxima Centauri b is a rocky planet like the Earth. This exoplanet is located in the habitable zone of the star, although it is 7.7 times closer to Proxima Centauri than Mercury is to the Sun. This is because Proxima Centauri is a red dwarf. It therefore emits less energy and heat than a yellow dwarf like the Sun, or a white dwarf like Sirius. Its habitability zone, i.e., the zone where water could be found in liquid form thanks to temperatures that are neither too cold nor too hot, is therefore closer than the habitability zone of the Sun, in which the Earth and Mars are located. However, studies conducted on Proxima Centauri b to determine if life would be possible there have not had the expected conclusion. Astronomers note that Proxima Centauri b is 250 times more exposed to X-rays than Earth, which would make life as we know it impossible. And even if the planet had an atmosphere, it would not withstand the repeated onslaught of frequent eruptions from the red dwarf Proxima Centauri. However, even though it is unlikely that life would survive on such a planet, some astronomers remain optimistic. There are so many exoplanets orbiting red dwarfs that it is likely that there are forms of life that we do not suspect are doing very well there. We might be surprised by the adaptability of some life forms. In fact, Lisa Kaltenegger and Jack O'Malley James, two researchers from the Carl Sagan Institute at Cornell University in New York State, have published a paper along these lines in 2019 in the journal Monthly Notices of the Royal Astronomical Society. Their argument is well thought out. The Earth, in its infancy 3.9 billion years ago, endured even worse storms than Proxima b is currently experiencing, and yet life was able to resist and thrive. The researchers compared the characteristics of the atmospheres of Proxima Centauri b and 3 other near-Earth exoplanets to those of Earth. They compared parameters such as atmosphere composition and thickness, and compared these results to those of the Earth's atmosphere over the course of its history. Of course, for these comparisons, models were used, since the atmospheres of these exoplanets have never been directly observed, only deduced via the mass or density of the planets. The results of this study indicate that even if the atmosphere of Proxima Centauri b is eroded and devoid of oxygen, the UV radiation at the surface remains below the levels known by the primitive Earth, including during the eruptions of the red dwarf Proxima Centauri. Conclusion: UV radiation is not a limiting factor for the habitability of rocky planets around red dwarfs. In January 2019, about 3.5 years after the discovery of Proxima Centauri b, a second planet was detected, orbiting the star Proxima Centauri. This planet was named Proxima Centauri c. The existence of this exoplanet is not yet confirmed, but it would be a super-Earth, i.e., an exoplanet with a mass between that of the Earth and that of a giant planet. Its mass would be at least 5.8 times that of the Earth, and its orbital period would be 1,928 days, or a little more than 5 Earth years. Proxima Centauri c could also be a mini Neptune, i.e., a gas dwarf planet with a rocky core and surrounded by a thick atmosphere. Because of its large mass and distance from its star, Proxima c is probably not habitable. Its equilibrium temperature is estimated to be minus 234 degrees Celsius, or minus 389 degrees Fahrenheit. More recently, in February 2022, a team of astronomers using the Very Large Telescope VLT of the European Southern Observatory, ESO in Chile, detected the presence of a third exoplanet around Proxima Centauri. This planet has been named Proxima Centauri d. It would be one of the lightest exoplanets detected to date around a star. The Proxima Centauri planetary system continues to surprise us and to break records. It is not surprising that many teams of astronomers have been studying this stellar system close to our own. The radial velocity technique was used to discover Proxima Centauri d, a very light exoplanet. When a planet orbits its star, it makes it move. This movement modifies the light spectrum that our instruments on Earth capture from this star. An object approaching us is red-shifted, while an object approaching us is blue-shifted. This shift is proof that the star is moving, and that an object is orbiting it. Proxima Centauri d would have a mass equivalent to a quarter of that of the Earth, and it would orbit its star in about 5 days. It is located very close to its star, about 1/10 the distance of Mercury to the Sun. According to the first estimates, it would not be habitable. But this statement should be taken with caution in the absence of information on the presence or absence of an atmosphere that could generate a greenhouse effect. Of the 3 exoplanets discovered around the star Proxima Centauri, Proxima b, the first to be discovered, is the most likely to be inhabited. However, we could not physically go there with our current means of propulsion. Take the example of the New Horizon probe, which travels at a speed of 17 kilometers per second, or 10 miles per second. At this speed, it would take us 78,000 years to reach Proxima b, and yet it is the closest exoplanet to Earth. Astronomers can only imagine what life would be like on this planet if they cannot see it with their own eyes. Like most planets orbiting red dwarfs, it would be in synchronous rotation around its star, and would therefore always present the same face. One could therefore imagine that one side would be immersed in darkness with very cold temperatures, and the other would be constantly exposed to very high temperatures. The liquid water and the life could, on the other hand, develop at the border between these two zones. You will see in the rest of our journey that most exoplanets orbiting a red dwarf are in this configuration because of the tidal effect. Let's continue our journey towards Wolf 1061. Before going further, let's stop at 8.3 light-years from Earth, where the fourth closest exoplanet to our solar system ever detected is located, after the 3 exoplanets of the Proxima Centauri system. This exoplanet has been named GI 411b. It was detected by an international team of astronomers in 2019 at the Hot Province Observatory, thanks to the SOFI spectrograph installed on the observatory's 1.9-meter or 6 feet telescope. The telescope of the Observatory des Hautes Provinces is the one which allowed the discovery of the very first exoplanet in 1995, 51 Pegasi b. For the record, 51 Pegasi b orbits a yellow subgiant, a class of stars brighter than yellow dwarfs but less than yellow giants. It is located 51 light-years from us. At the time, no exoplanet closer to Earth had been discovered. This is not the only record that was broken by 51 Pegasi b. Astronomers also had to create a new type of planets to characterize it, because until then, no gas giant as close to its star had been discovered. 51 Pegasi b is therefore what is called a hot Jupiter. Let's go back to the fourth closest exoplanet to our solar system, GI 411b. In 2019, when it was discovered, GI 411b was the third closest known exoplanet to Earth. But it has since been dethroned by Proxima Centauri d, discovered in 2022. The mass of GI 411b is equivalent to 3 times that of the Earth. It orbits the star GI 411 in the Big Dipper constellation in 13 days and is probably rocky. It is very close to its star, only 0.08 astronomical units away, about 5 times closer than Mercury to the Sun. To discover the exoplanet GI 411b, astronomers looked at the observation of red dwarfs. It is easier to find an exoplanet around a red dwarf. First, because these stars represent 80% of the stars in our galaxy. Second, because their mass, much smaller than that of the Sun, makes them more sensitive to the gravitational influence of the planets orbiting around them, which makes them more easily detectable. This is how the SOFI spectrograph detected the exoplanet GI 411b. By detecting the motions caused by the planet's mass on its star as it orbits the red dwarf. The observations gathered on GI 411b do not lean in favor of a possible life on the surface of the exoplanet. It is very close to its star, and even though red dwarfs are cooler than yellow dwarfs, it is still too close to be in the habitable zone of GI 411. It could be that this rocky planet is more like Venus than Earth. GI 411b is not a novelty for the Hot Province Observatory, which has already detected nearly 200 planets. But it is very interesting because of its proximity to our solar system. The observation of this planet in the years to come, and especially of its atmosphere, will be crucial for the astronomers, who will be able to compare their observations with the characteristics of the planets of the solar system. Thanks to its proximity to the Earth, GI 411b, like the planets of the Proxima Centauri system, can be observed directly. Let's continue our journey in the universe to discover the closest exoplanets to Earth. Not far from GI 411b is the exoplanet Ross 128b, located 11 light-years from our planet. Discovered in 2017, the exoplanet Ross 128b orbits a red dwarf, Ross 128, and was detected with the HARP spectrograph at the La Silla Observatory in Chile It is the closest exoplanet to Earth that could potentially be inhabited, because the star Ross 168 is a rather quiet red dwarf. Its eruptions are less frequent and less violent than those of other red dwarfs, which would increase the chances of preserving the atmosphere of Ross 128b if it had one. If Ross 128b contained liquid water, it would be much more favorable to the development of life than Proxima Centauri b, which is constantly bombarded by harmful X-rays and ultraviolet radiation. Although the exact mass of Ross 128b is not known, nor its radius, astronomers have deduced that it has a low mass and is therefore probably rocky with a solid surface like the Earth. To complete these assumptions, there are models that can give us hypothetical information about this exoplanet. According to the models, Ross 128b would probably have a mass 35% greater than that of the Earth, and its radius would be 10% greater. It would receive only 38% more light than our planet, and its equilibrium temperature would be rather stable, between minus 60 degrees Celsius and plus 20 degrees Celsius, or between minus 76 degrees Fahrenheit and plus 68 degrees Fahrenheit. Its rotation period would be about 9.9 Earth days, and its rotation would be synchronous. It would orbit 20 times closer to its star than the Earth to the Sun, about 7.4 million kilometers or 4.6 million miles from its star. It is not yet known if it is located in the habitable zone of its star, because everything depends on its characteristics, in particular, on the composition and thickness of its atmosphere. It would most likely be located at the edge of the habitable zone, but nothing is confirmed yet. According to calculations, Ross 128b has a similarity index with the Earth of 0.86, which makes it the third exoplanet with the highest similarity index. The planet with the highest Earth similarity index is TRAPPIST-1b, with an ESI of 0.90, and the second planet is Kepler-438b, with an index of 0.88. But both of these planets are farther away from us, which makes Ross 128b particularly interesting for astronomers. TRAPPIST-1b remains relatively close, but is still 40 light-years away. As for Kepler-438b, it is very distant, about 475 light-years from our solar system. It is difficult at this time to study the characteristics of the atmosphere of Ross 128b because it does not transit in front of its star. To learn more about this candidate for extraterrestrial life relatively close to us, we must wait for the launch of larger telescopes, such as the ELT, the Extremely Large Telescope, built by ESO, and still under construction in the Atacama Desert in Chile. The ELT, but also the James Webb, will be able to analyze the composition of its atmosphere without using the transits method. On the other hand, here is a piece of information that should give you chills. If Ross 128b was inhabited by an advanced extraterrestrial civilization, then it could have observed the Earth in transit in front of the Sun. Potential aliens from Ross 128b know that we are here and have even had time to determine the characteristics of our planet and its atmosphere. Enough to give you a chill. Let's continue our journey into the heart of the universe in search of the closest habitable planets to Earth. YZ Ceti is a multi-planetary system located 12 light-years from Earth, just next to Ross 128b, as seen from Earth. The particularity of this star system is that scientists have discovered 3 Earth-like exoplanets. It is the second closest multi-planetary system to us, after the Proxima Centauri system. YZ Ceti is a red dwarf in the constellation Whale, which cannot be seen with the naked eye from Earth despite its relative proximity. Its mass is 13% that of the Sun, and its radius is 17% that of our star. It is an eruptive or variable star, which means that it undergoes fluctuations in brightness. In other words, its brightness can increase briefly and suddenly due to flares or stellar spots that move as the star rotates. On August 10th, 2017, was announced the discovery of 3 Earth-like exoplanets around the star YZ Ceti. It is also possible that there is a 4th planet. It would then be one of the smallest planets ever discovered. All 3 planets are too close to the star to be in its habitable zone, but they are all similar in size to Earth. According to astronomers' estimates, they would not exceed 1.5 times the size of the Earth. YZ Ceti b is the closest planet to the star. It goes around it in less than 2 days. It is very close to YZ Ceti, only 0.016 astronomical units from its star. For comparison, 1 astronomical unit is the distance between the Earth and the Sun. It is also the least massive of the 3 exoplanets in this multi-planetary system, with a mass of 0.75 times that of the Earth. YZ Ceti c is located 0.021 astronomical units of the star, and it makes the turn in 3.06 days. Its mass is 98% that of the Earth. Finally, the most distant planet from the star among the 3 exoplanets is YZ Ceti d. It is separated from its star by 0.028 astronomical units, and it goes around in 4.66 days. Its mass is estimated at 1.14 times that of the Earth. The 3 exoplanets of the YZ Ceti system were detected by radial velocity with a HARP spectrograph at the La Silla Observatory in Chile, like Ross 128b. It is not yet known if they can be observed from Earth with a transit method. Their observation would be interesting for astronomers to continue to understand the formation of planets. But unfortunately, there is little chance that these exoplanets, very close to their star, are inhabited. Not far from YZ Ceti on the scale of the universe, you can see the exoplanet Luyten b, 3rd planet with the highest similarity index to the Earth, ex Aquio, with Ross 128b. We are 12.2 light-years from Earth. This planet is also called GJ 273b. It is in orbit around a red dwarf, the star of Luyten, and it is a telluric planet. It was discovered at the same time as another planet, which also orbits the star of Luyten, Luyten c. But it is Luyten b that interests astronomers because it falls into the category of super-Earths. Its mass is equivalent to almost 3 times that of the Earth, and it receives only 6% more sunlight than the Earth. It could therefore be habitable. This is what the non-profit organization METI has sought to verify. The acronym METI stands for Messaging Extraterrestrial Intelligence, which could be translated as sending a message to an extraterrestrial intelligence. And indeed, that is the goal of this organization, to seek ways to communicate with extraterrestrials and send them messages in hopes of one day getting a response. In October 2017, the METI organization sent a message to Luyten B in hopes of making contact with a potential extraterrestrial civilization. These, if they receive and understand our message, could respond by 2042. The message that has been sent is at the same time musical, mathematical, and scientific, and it is coded in radio waves to maximize its chances of being understood by an advanced extraterrestrial civilization. The METI organization was contacted by the Sonar Festival of Barcelona, a music and technology festival, to develop a message that would be sent into the cosmos to celebrate the 25th anniversary of the festival. The signal was named Sonar Calling GJ273b. It was sent from the ESCAT transmitter in Tromsø, Norway, over 3 successive days in October 2017. Among other things, it contains a tutorial on basic math and science, explaining physical concepts specific to our civilization, such as radio frequencies or our conception of time. In a way, a practical manual so that the aliens can understand the musical message and respond to us with the same communication process. In addition to the tutorial, the message includes 6 original pieces of music, commissioned by the Sonar Festival, short 10-second pieces of music. You may wonder why the Sonar Festival chose the planet Luyten B, and not, for example, Proxima B, whose habitability is still in question, and which is closer to us. Simply because the star of Luyten is visible from the northern hemisphere, where the transmitter is located. It is therefore more convenient to communicate effectively with potential extraterrestrials. We have now arrived at our destination, about 14 light-years from Earth. You are looking at the Wolf 1061 star system. Before we continue our exploration of the nearest habitable exoplanets to Earth, you need to understand why astronomers are looking for alien life on these exoplanets, and how they go about determining whether or not a particular exoplanet might harbor life. Why are we looking for life on exoplanets when it is very likely that we will never be able to communicate with the life forms that will have been discovered? You may be asking yourself this question, which is quite sensible, because even if a giant telescope allows us to find life on an exoplanet located several tens of light-years away, several things could prevent us from entering into communication with this life. These are the same reasons that are given in response to the Fermi paradox, the paradox that wonders why, if there is life elsewhere than on Earth, extraterrestrials have never manifested themselves. First of all, it is possible that this life is microbial, aquatic, or animal, and that it does not understand us. And even if an advanced extraterrestrial civilization is found, its communication processes will be so different from ours that communication may be impossible. It is also possible that intelligent civilizations have existed, but that they did not last long on the scale of the universe. They would have quickly self-destructed because of technology, a nuclear war, or other. Or they have already tried to communicate with us, but we did not understand their signs, because their communication techniques are still too advanced for us. We can imagine dozens of answers to the Fermi paradox. But all we know is that the presence of extraterrestrial life elsewhere in the universe is not yet certain, and that perhaps the Earth is an exception. We also know that if another form of life is found elsewhere in the universe, it is very unlikely to come across another civilization that is as advanced as ours. So why are we looking for life on exoplanets? Not only to make contact with extraterrestrials, but also to better understand the appearance of life on Earth, and to find out if Earth is an exception. Currently, the Earth is an exception in the universe because it is the only known planet that hosts life. But perhaps our place in the universe is not so exceptional. Scientists are also interested in the question of whether life could exist in other forms. The life we know is based on 6 atoms: hydrogen, oxygen, carbon, potassium, nitrogen, and phosphorus. We have not yet observed other types of life, but that does not mean it is unlikely. This is the subject of exobiology, a discipline that imagines what living things based on elements different from ours might look like, using notions of astrophysics, planetology, biology, and chemistry. To find life on exoplanets, astrophysicists will proceed step by step. First, the idea is to detect an exoplanet by the transit method, or by radial velocity. The transit method is the most used method to detect exoplanets, but it has some limitations. The exoplanet HD 209458b, located 159 light-years away, was the first exoplanet to be discovered with this method. When a planet passes in front of its star, which is called transit, we observe a decrease in the luminosity of the star. This decrease in brightness of a few percent is measurable by photometry. The transit method allows us to deduce certain characteristics of an exoplanet: its period of revolution, its radius, and even, with precise instruments like the James Webb, certain elements present in its atmosphere. But this method has its limits. The planet must pass in front of its star to be detected, an event that is actually quite rare on the scale of the universe. For example, to see Venus pass in front of the Sun, we would have to wait a century. Once astronomers have detected an exoplanet, whatever the method used, they will deduce its characteristics to be able to establish if the planet is in the habitability zone of its star. This is called Goldilocks. The goal is to know if the planet can contain water in a liquid state, which is essential for the development of life as we know it. A planet too close to its star would be too hot, and the water would evaporate, and conversely, a planet too far from its star would be too cold, and the water would freeze. The balance is tenuous. You now understand why, while more than 5,000 exoplanets have been discovered to date, scientists are not yet certain that other forms of life exist elsewhere than on Earth. But being in the habitability zone of its star does not necessarily make the planet habitable. We have a good example in our solar system with Venus, often called the twin sister of the Earth. Astronomers say that until 715 million years ago, Venus was quite habitable, with large oceans like on the primitive Earth. In fact, Venus is very similar to Earth, with a similar mass and size, so it makes sense that they would have been similar in their early existence. But today, Venus is uninhabitable, with an average surface temperature of about 450 degrees Celsius, or 842 degrees Fahrenheit, and sulfuric acid rain. 715 million years ago, something caused a massive injection of carbon dioxide into Venus's atmosphere, creating an uncontrolled greenhouse effect that has resulted in the planet's hellish environment today. The profile of a habitable planet would therefore finally be quite similar to that of Earth, a rocky planet with an atmosphere neither too small nor too massive. These characteristics are modulated according to the type of star and the distance between the star and the planet. To confirm whether a planet is habitable or not, astrophysicists will not rely solely on its distance from its star or its surface temperature. They will look for biosignatures, in particular, photosynthetic biosignatures, which the largest telescopes today can detect. Now that you know how astrophysicists determine whether or not an exoplanet is habitable, and why they are constantly searching for an Earth-like habitable planet, we can begin to explore the Wolf 1061 system and its planet, Wolf 1061c. The Wolf 1061 star system is organized around the red dwarf, Wolf 1061, located about 14 light-years from us in the zodiacal constellation of Serpentarius. This star is also known as HIP 80824 and V2306 Ophiuchi. For the record, red dwarfs have the ability to burn up to 400 to 500 billion years, 40 to 50 times longer than our Sun. Around this red dwarf orbits at least 3 telluric planets. Wolf 1061c is the one we are interested in today because it is classified as a super-Earth and is located in the habitable zone of the star Wolf 1061. The star Wolf 1061 was first catalogued in 1919 by the German astronomer Max Wolf. This astronomer had published a list of faint stars that had a high proper motion. The proper motion is the apparent motion of the stars on the sky, as seen from the Earth. Later, the star Wolf 1061 attracted the interest of astronomers for its relative proximity to the Earth. Using the radial velocity method, astronomers discovered a triple planetary system consisting of 3 planets, Wolf 1061, B, C, and D. The habitable zone of the star Wolf 1061 is estimated to be between 0.1 and 0.2 astronomical units from the star. The planetary system of Wolf 1061 consists of 3 known planets. It is not excluded that there are others. These planets were detected by analyzing 10 years of observations of the Wolf 1061 system by the HARP spectrograph at the La Silla Observatory in Chile. The team of astronomers behind the discovery used radial velocity measurements of the star's spectrum to highlight these 3 exoplanets and their orbital periods. Wolf 1061b orbits the star in only 5 days, while Wolf 1061c takes 17.9 days to circle the star, and Wolf 1061d, further out, orbits in 217 days. The mass of Wolf 1061c is estimated to be at least 4.3 times that of the Earth, making it a super-Earth. The mass of Wolf 1061b is closer to that of the Earth because it is estimated to be at least 1.4 times that of the Earth, while the most distant planet is 5.2 times the mass of our planet. The 3 exoplanets of the Wolf 1061 system have masses low enough to be rocky planets, but this remains a supposition since we know neither their size nor their density. If this were the case, they would probably have a solid surface. To be able to determine these characteristics and to know more about the planets of Wolf 1061, it would be necessary to use the transit method. Even if for the moment no transit has been observed from Earth, astronomers do not give up hope of seeing a transit because the 3 exoplanets have short orbital periods. The chances of seeing a transit are 14% for Planet B, 6% for Planet C, and 3% for Planet D, according to the team of astronomers from the University of New South Wales in Australia. Of the 3 exoplanets in Wolf 1061, only Planet C is considered potentially habitable. Wolf 1061b is too close to its star, and Wolf 1061d is located at the outer limit of the habitable zone. Its habitability remains probable because everything depends on its own characteristics, which could not be observed. But while waiting to know more, it is the middle planet, Wolf 1061c, that interests astronomers. Wolf 1061c has long been considered the closest potentially habitable exoplanet. After the discovery of exoplanets closer to our solar system, it is part of the growing list of the closest potentially habitable exoplanets, along with Proxima Centauri b, Ross 128b, and Luyten b. It is, after Proxima Centauri b, the second potentially habitable planet in a triple planetary system. Wolf 1061c is a super-Earth located near the inner limit of the habitable zone of Wolf 1061. The habitable zone of the red dwarf has been estimated by astronomers to be between 0.11 and 0.21 astronomical units, or at most between 0.09 and 0.23 astronomical units. Wolf 1061c is located at 0.08 astronomical units from its star, thus at the lower limit of the habitable zone. It is called a super-Earth because its radius has been estimated to be more than 1.5 times that of the Earth. Its mass is 4.3 times that of the Earth, and its surface gravity is estimated to be 1.6 times that of the Earth. All these estimates have allowed astronomers to assume that Wolf 1061d should have a density close to or greater than that of the Earth. Other characteristics of Wolf 1061c could be estimated from the astronomers' observations. Its orbital period is 17.9 Earth days, and its equilibrium temperature is about -50 degrees Celsius or -58 degrees Fahrenheit, slightly higher than the equilibrium temperature of Mars. Wolf 1061c receives less than 1% of the Sun's luminosity. All these characteristics are only guesses at the moment, because the observation of Wolf 1061c was made with the radial velocity method. To know more, and to confirm the estimates of the astrophysicists, it would be necessary to observe a planetary transit. The method of transits would give us a more certain estimate of the radius, and thus of the density of the planet. We could then know if Wolf 1061c is an ocean planet or not. Because it is very close to its star, Wolf 1061c is certainly in synchronous rotation. As we saw at the beginning of this journey with the exoplanet Proxima Centauri b, it is indeed very likely that there is a tidal effect that makes the planet turn on its axis at each revolution around the star. This tidal effect would be explained by its proximity to its star, Wolf 1061. The planet Wolf 1061c would therefore always present the same face to its star, and could therefore harbor life only in the zone of separation between the diurnal face and the nocturnal face. This fictitious line between the illuminated zone and the zone perpetually plunged into darkness is called terminator. Unless the atmosphere of Wolf 1061c is thick enough for there to be a heat transfer from the day hemisphere to the night hemisphere. If Wolf 1061c were in our solar system, it would be too hot to harbor life because of its proximity to its star. But Wolf 1061, which is a red dwarf, is much cooler than our Sun. For comparison, its surface temperature is about 3,030 degrees Celsius, or 5,480 degrees Fahrenheit, while the surface temperature of our Sun is around 5,530 degrees Celsius, or 10,000 degrees Fahrenheit. Wolf 1061c is therefore well and truly in the habitable zone of its solar system. But to know if Wolf 1061c harbors life, it would be necessary to study its atmosphere. Being in the habitable zone is not enough for life to develop on a planet. As we have seen, the example of Venus is enough to understand that a planet can be rocky like Earth and located in the habitable zone of its star, but have characteristics that make life impossible. Astronomers have estimated that life could have developed on Venus for about 3 billion years because the planet's climate was then stable and temperate like Earth's, between 20 and 50 degrees Celsius, or 68 and 122 degrees Fahrenheit. But about 700 to 750 million years ago, a cataclysmic event caused a massive release of carbon dioxide into Venus's atmosphere, a gas that had previously been trapped in the planet's rocks. Some researchers believe that this event resulted from the strong volcanic activity of Venus. The result? An intense greenhouse effect and rising temperatures that have reshaped 80% of Venus's surface. Today, the planet that was considered as the twin planet of the Earth has an average surface temperature of 450 degrees Celsius, or 842 degrees Fahrenheit, and is considered as the hottest planet in our solar system. Venus was the victim of a runaway greenhouse effect. Heat became trapped in the atmosphere, and the planet became too hot for any form of life. Researchers estimate that during the 3 billion years that the planet was habitable, its landscape strongly resembled those of the primitive Earth, with lakes and oceans. These oceans eventually evaporated because of the heat, which only increased the surface temperature of Venus, since water vapor is a real heat trap. A vicious circle that has shaped the planet we know today, often referred to as an iron planet. In the same way as Venus, if the atmosphere of Wolf 1061c is rich in greenhouse gases, it could be too hot for it to be habitable, even if it is rocky, with characteristics close to those of the Earth, and is located in the habitable zone of its star. Stephen Kane, an astronomer specializing in exoplanets at San Francisco State University, and his team have studied the question of the habitability of Wolf 1061c. According to them, the climate of this exoplanet is rather chaotic. On Earth, climatic changes occur at a rather slow pace, since the Earth's orbit lasts 365 days. But on Wolf 1061c, which orbits its star in only 18 days, these climatic variations would be much faster. The frequency of freezing or warming would therefore be very fast. Imagine living on a planet where it is successively very hot and very cold, without transition. That said, astronomers are still waiting for more data on the planet's atmosphere to be able to make a statement. It is possible that the very short periods of freezing are sufficient to cool the planet, but it would be necessary to push the observations even further to confirm one of these hypotheses. Moreover, according to Stephen Kane and his team, because it is located very close to its star, it would be quite possible that Wolf 1061c, like Venus, experiences an uncontrolled greenhouse effect. There is, however, another argument in favor of the planet's habitability. Like Ross 128, the star Wolf 1061 is particularly quiet for a red dwarf. Most red dwarfs are very active and are prone to superflares that would destroy any life on nearby planets. Especially since red dwarfs are cooler than yellow dwarfs like our Sun, planets orbiting red dwarfs are located much closer to their star than the planets in our solar system. Scientists are not yet sure that Wolf 1061c harbors life. We have too little information to say with certainty that this exoplanet relatively close to our Earth is a paradise, a hell, or something in between. Let's assume that Wolf 1061c is potentially habitable. So what would life be like on this exoplanet, 14 light-years away from our solar system? Many researchers claim that humans could not live on this planet. It's true that planets within a star's famous habitability zone are likely to contain liquid water, one of the prerequisites for the development of an advanced civilization like ours. But researchers believe that in the case of Wolf 1061c, the development of life similar to the one we know would be very complicated. The living conditions for humans would not be pleasant, with a gravity 1.6 times greater than that of the Earth. In addition, its synchronous rotation implies that there is a side of the planet perpetually plunged in the dark, with very low temperatures, and another side without ever nights, with very high temperatures. Humans might be able to survive in the middle zone, the terminator, but they would not live comfortably there. And it is unlikely that in these conditions a species similar to ours, the result of evolution and adaptation to our terrestrial environment, would have been born. But this does not exclude other types of animal or plant species. The question that also arises is that of the conditions of life on a planet orbiting a red dwarf. The synchronous rotation and its two opposite hemispheres are not the only obstacles to the development of a species, such as man on the planet Wolf 1061c. Living next to a red dwarf is not easy. These stars are known for their frequent eruptions, which emit UV and X-rays, dangerous for human life, and for that matter for all forms of life. The surroundings of a red dwarf star are therefore not a very hospitable environment. Yellow dwarfs like our Sun can have outbursts of anger, like red dwarfs. But in addition to being less frequent, they are less dangerous because the planets orbiting a yellow dwarf are more distant than those orbiting a red dwarf. The Earth is far enough from the Sun not to fear possible eruptions, and we are protected by the magnetic field and by our atmosphere. Planets orbiting red dwarfs are too close, and even if they have an atmosphere, it can be torn apart by the onslaught of stellar flares. Scientists believe that there is a cumulative effect. That is, the more flares there are, the more the atmosphere is torn apart, regardless of the violence of the flares. So yes, recent studies have found that red dwarf eruptions are not as energetic as has been thought for years. Researchers may have overestimated the violence of red dwarf flares, but if the cumulative effect exists, it is the frequency and not the violence of the eruptions that is dangerous. However, not all astronomers are pessimistic about the possibility of life developing in the orbit of a red dwarf. Red dwarfs represent 3/4 of the stars in the Milky Way, and we have already discovered many that are surrounded by rocky Earth-like planets. What would be strange is that among all these planets, which are so many possibilities for the emergence of life, there is not a single form of life that is developed. Other factors may affect the habitability of a planet located near a red dwarf. The characteristics of its atmosphere, its thickness, its liquid water content, the interactions between the magnetosphere and the ionosphere with stellar winds. If the right factors are present, an exoplanet of a planetary system organized around a red dwarf could be habitable by creatures other than humans who would resist other conditions. Moreover, the case of Wolf 1061c is promising, since Wolf 1061 remains a rather quiet red dwarf, with relatively low power and infrequent eruptions. Suppose there were life on the planet Wolf 1061c. The conditions for life would be very different from those on Earth. Imagine a world where there are only days or only nights, depending on where you are. The years would also be shorter, since Wolf 1061c orbits around its star in only 18 days. A year would last barely 3 Earth weeks. Because Wolf 1061c orbits a red dwarf and not, like the Earth, a yellow dwarf, the landscapes would also be very different, as well as the luminosity of the planet. Our sun emits yellow radiation, but red dwarfs emit a reddish radiation. The inhabitants of Wolf 1061c would still have a red star above their heads, and the stellar disk would be larger than that of the sun, since the red dwarf is closer to Wolf 1061c than the sun is to the Earth. It is possible that there are plants on Wolf 1061c because plants have a photoreceptor for red light, phytochrome, a blue-green pigment found in plant cells. However, the plants on Wolf 1061c would be very different from terrestrial plants, whether in terms of flavor, smell, or appearance. They would probably be black to better absorb the red light emitted by the star. You may find it difficult to imagine a flourishing life but limited to a small strip in the middle of the planet. This is normal. This representation is very far from what we know. But the good news is that if there is life on Wolf 1061c, it is not necessarily limited to the terminator if the atmosphere has the right characteristics. For a very long time, astronomers believed that life on synchronously rotating planets was only possible in the terminator zone. They also thought that for heat transfer to be efficient enough from the day side to the night side, the atmosphere would have to be so thick that it would prevent photosynthesis. It was also thought that such planets would experience high winds and torrential rains all the time, making any complex life forms unlikely. Here is what life looked like according to these assumptions. There are no humans, but plants can survive in such an environment. They can adapt to the constant winds, for example, by anchoring themselves in the ground with their roots, or by developing flexible and unbreakable leaves and branches. There are also animals which communicate by infrared rather than by cries and smells as on Earth, because storms make this type of communication impossible. Underwater life is protected from strong winds and eruptions by the water, and is supported by vast blooms of plankton and black photosynthetic algae. A plankton bloom is when phytoplankton multiply in an ocean. On Earth, this phenomenon has been demonstrated in the depths of the Arctic Ocean and under the sea ice in Antarctica. We can see it forming like a green sheet from space. This phenomenon can only occur if two elements are combined. nutrients, and light from the star. We can therefore imagine that these forms of underwater life would develop in the oceans of the illuminated hemisphere of Wolf 1061c. Further studies were conducted from the late 20th century onwards with promising results. Astronomers are now a bit more optimistic about the emergence of life on this type of exoplanet. Studies conducted at the end of the 1990s by NASA researchers have shown that the atmosphere of a planet, if it does contain the greenhouse gases CO2 and H2O, only needs 100 millibars, or 10% of the Earth's atmosphere, for the heat of the star to be transported to the night side. This figure is reassuring because it shows that photosynthesis could then take place. Other studies have shown that in the night side, seawater can circulate efficiently without freezing if the ocean basins are deep enough for the water to circulate under the ice cap. In other words, one could very well find underwater life in a synchronously rotating ocean world, even on the night side. A 2010 study estimated that ocean temperatures would not fall below -33 degrees Celsius or -27 degrees Fahrenheit in the hemisphere perpetually immersed in night. For the difference between the day and night side to be minimal, there would have to be clouds. If Wolf 1061c has clouds, then astronomers agree that this greatly increases its chances of being habitable. Wolf 1061c could be an ocean planet. Maybe you have a hard time picturing what this type of planet looks like. Scientists describe them as a planet that would be covered with an ocean or water over its entire surface. The depth of this ocean could be several tens of kilometers, but this type of planet remains hypothetical. For the moment, we can only think about the hypothesis according to which Wolf 1061c would be entirely covered with water without really any evidence to confirm or deny this hypothesis. If Wolf 1061c were an ocean planet, it would be covered with high-pressure and high-temperature oceans. To date, astronomers do not know if this environment would be conducive to biological chemistry. What we do know is that if the oceans of Wolf 1061c were to support life, it would certainly be different from the underwater life found in our terrestrial oceans. We know that the oceans are capable of wonders. The origin of life on Earth remains mysterious, but the most likely hypotheses agree that it was born in our oceans, or at least in water. Underwater life can survive extreme conditions. On Earth, we have found living organisms capable of developing in the Dead Sea. The tardigrade is the best example of an ultra-hardy species that can survive incredible pressure conditions. This 8-legged animal, which can grow to just over 1 millimeter, can withstand temperatures ranging from -273 degrees Celsius or -460 degrees Fahrenheit to +150 degrees Celsius or 300 degrees Fahrenheit, but also X-rays, to which it is 1,100 times more resistant than humans, and pressures 4 times greater than those of the deepest ocean. It can also resist to the lack of oxygen or to the isolation because it reproduces alone. It is cryptobiosis that allows it to be so resistant, a state in which it reduces its metabolic process to 0.01% of normal, so that it is almost dead but not quite. It can remain in this state for decades and rehydrate to wake up at any time. It is therefore quite possible that living organisms of this type can be found on planets like Wolf 1061c, where conditions are less mild than on Earth. There is still much to discover about the secrets of the exoplanet Wolf 1061c. There are many rocky planets in our galaxy, but some of them are located tens or hundreds of light years away from us. Wolf 1061c is one of the most promising because it is close to Earth. The next step to establish an ever more precise portrait of this promising exoplanet is to observe its transit. The transit method will provide crucial information to better understand this planet and determine if it may contain life. When Wolf 1061c passes in front of its star, it will cause a decrease in brightness at Wolf 1061. Scientists will then be able to analyze this difference in brightness to deduce the composition of its atmosphere. The higher the orbital period of an exoplanet, the more difficult it is to apply the transit method, because transits are rarer. In the case of Wolf 1061c, the orbital period is short, which suggests that a transit will be observed rather quickly. Moreover, when the transit method is applied to discover an exoplanet, it is necessary to have observed several transits to conclude that there is a planet in orbit around the observed star. The transit method provides information such as the radius and density of the exoplanet. Astronomers know the spectrum of the star, so they can derive the value of its radius. The relative decrease in the luminosity of the star during the transit is equal to the square of the ratio of the radius of the exoplanet to that of its star. This calculation allows to obtain the radius of the exoplanet. By confronting the radius to the mass, we then deduce the average density. The transit method also provides information on the chemical composition of the planet's atmosphere, as well as its temperature. To do this, astrophysicists measure the spectrum of the star without transit, then with, to deduce the spectrum of the exoplanet. The James Webb Telescope, which was launched in December 2021, will greatly help scientists learn more about Wolf 1061c, its unique characteristics, and whether or not it harbors life. The Space Telescope carries several instruments that allow it to see in the near and mid-infrared. Moreover, in August 2022, the scientific community announced that James Webb had detected the presence of CO2 in the atmosphere of an exoplanet for the first time. This exoplanet is WASP-39b, a gas giant the size of Saturn. It was one of the first exoplanets examined by James Webb from July 2022, and there is no doubt that Wolf 1061c is on the waiting list. Even more impressive, the telescope was able to detect, in addition to CO2 water vapor, carbon monoxide, sodium, potassium, and sulfur dioxide. The detection of this last compound has highlighted a photochemical phenomenon observed for the first time on an exoplanet. The James Webb Telescope is not the only one to be promising. The extremely large telescope of ESO, the European Southern Observatory, should be completed and put into service in 2028. This telescope, currently under construction in the Atacama Desert in Chile, will be the largest ground-based telescope ever built, with a main mirror 39 meters in diameter. For comparison, the James Webb Telescope orbiting the Sun, 1.5 million kilometers or 930,000 miles from Earth, has a mirror 6.5 meters or 21 feet in diameter. The European Southern Observatory's Very Large Telescope has already demonstrated its capabilities by discovering barium in the atmosphere of the exoplanets WASP-76b and WASP-121b in October 2022, the heaviest element ever found in the atmosphere of an exoplanet. So, imagine what the ELT's capabilities will be. This super powerful telescope, when completed, will stand 3,000 meters or 10,000 feet above the Earth and will capture 100 million times more light than the human eye. We are coming to the end of this journey in the Wolf 1061 planetary system. Now you know that in the universe there are many rocky planets and many multi-planetary systems like ours. If astronomers have not yet found a second solar system, they do not lose hope that one day they will find a planet on which life would abound. Wolf 1061c is a promising exoplanet, which has the advantage of being very close to us. The new telescopes, first the James Webb and then the ELT, will be able to tell us more about this exoplanet, its characteristics, whether it is suitable for life, and above all, perhaps one day, answer the question that everyone is asking. What does life look like 14 light years away from our planet?